Hello, this is Jason Hendler, and now I'm going to do the offset shaft that's on 131 to 149. And actually, this section extends beyond 149 into more auxiliary geometry type discussions. So, I'm definitely not going to cover all that because I discussed that in this reference geometry assignment that we did. Just showing you there's lots of ways to create planes, lots of ways to create axes. And I've covered that, so I won't go into any of that anymore. But I will do the offset shaft, so I'll be skipping around because if you look at page 133, you see there's only 5 panes as far as the major things that they're going to do, and so there really isn't a lot to this particular item. But anyway, we'll go ahead and do this. So we're going to create this offset shaft, and we're going to use the right plane to do it. And I'm going to go ahead and sketch in the right plane, and basically we want a 0.6 diameter circle. And I'm going to smart dimension 0.6, check. Okay. And in this one, this is one of those where we're doing one of these special tolerances and bilateral dimensioning type schemes. And so right now it says none, but here we want to do bilateral. And what we want to say is that it's plus 0, but it can be minus 0.005. And I'm going to make sure it shows that by selecting. So you need 3-point precision, and you need to be able to show 0 here and 5 there. So anyway, you hit check, and there is the call out for that. I need to go into options, document properties, dimensions, make sure everything's 3-point precision, just as a general rule. Then I'm going to do exit the sketch. Let me zoom in on this. And we're going to extrude it 6.5 inches. Blind. Okay, so there is the start of our shaft. The next feature is going to be a revolved cut, and the profile for that revolved cut is going to be in this front plane. Whoops, grab the wrong plane. Front plane. And so I'm going to sketch in this front plane. I'm going to go normal to, and I'm going to zoom in on this left side because that's where my sketch is going to be. I'm going to grab the corner rectangle, and make sure you draw your corner and you want this top edge highlighted because you want it to automatically align. When it's highlighted, it'll automatically align to it, and so as you dimension things, nothing's going to move around. So now I'm going to smart dimension, and if you look on page 135, it tells you what the dimensions of this is going to be. I'm going to go ahead and grab that plane, make this 0.5, going to make this dimension 0.063. I'm going to make this 0.063. Check. The next thing I need is a center line around which to revolve this. So again, you can add all kinds of geometry that doesn't affect your profile. And remember to hit escape after you draw a center line because that's the only way to stop drawing it. And you don't need to dimension anything, it's just there. So now when we go to features, and I'm going to go ahead and get back into this isometric view, zoom in so you can see our axis and you can see our sketch kinda. It's light blue, so it's a little hard to see. But if I do an extruded cut based on this sketch, why did I do that? Revolved cut, you can see that the preview shows up, and that's always the good news, because if the preview doesn't show up, then that means you did something wrong. Notice that it automatically selected this center line as our default axis as we want. Then you hit check, and now we have that feature in there. And so that's how you do the revolve cut. Now if you look through the next feature, they want us to do an offset plane, but then they get us going to page after page after page of how to do all these auxiliary planes and so forth. And it's hard for us to get back to what we were trying to do. But basically what we want to do is to create a plane that is 5 inches from the other plane. So it's interesting here. Let me go to a wireframe view, because it's just easier to see. So let's say we do want to create our reference geometry. We want to create a plane, and we want to create it off this surface, which is, but see, it's highlighting the cylindrical surface, and we actually want the surface that's on the other side of this. You can right click and select other, and it'll toggle through. Do you want this? Do you want this? You know, which one of these others did you want? And the other that we want is this first one, so we'll select that. Then it gives us a default plane that is, you know, 0.1 inch, but what we want, of course, is 5 inches away. So when I put in 5 inches and zoom out, notice I put it 5 inches in the wrong direction, but that's okay, because you can do flip and it'll put it over there, and that's where we want it. So then we hit check, and we've achieved the plane that we're looking for. Okay, so now we're going to create a groove just like the first one we did, but we're going to use a different process for it. We're going to use convert entities in order to make it. So fortunately, plane 1 is already selected here. So when I say sketch, sketch, it's going to be in this plane 1, and then I'll go normal 2. And yeah, it's fine if it flipped it around that way, because it's the same difference. And so to make this groove, we're now going to convert entities, and we're just going to convert that outside circle and this inside circle, and that's basically our sketch. And so now when I go to an isometric view, you can see that there is my sketch of the profile. And now we're just going to do an extrude cut. And right now it's blind at 6.5 inches, because that was the last dimension that we put in. What we want to do is just 0.063 inches, because that's the width of the O-ring groove, the other O-ring groove, so this would be the same. So now that we zoom in, we can see our preview looks like what we want, and so we'll just hit check, and we now have our O-ring groove. So if we look at this in a front plane, basically our two O-ring grooves look exactly the same. If I momentarily hide the planes, you can see that easier. So that groove is there and that groove. So dimensionally they look exactly the same. This one was a revolve cut, this was an extruded cut. You know, no big deal. They can be done either way. Again, this is just kind of showing off the features of SolidWorks, and not necessarily how you would do these things. Because honestly, wouldn't you just do a linear pattern of that first O-ring groove and not sit there and cut this one? But so that's how that works. The next thing that we're going to do is we're going to use the polygon tool. So that's what we're going to do. So if we look at 119, we can make a polygon using lines, dimensions, and geometric relations, but we really want to make it easy, so we'll use the polygon tool. Go to the menu and use the polygon tool. So I'm trying to find what sketch plane they're trying to use for this. So I think we're just coming off the end of the shaft. So if I select the end of this shaft and then I say sketch, sketch, and go normal 2. That'll be fine. And then here's the polygon tool. So if we select that, we can decide, you know, how many sides we want and all that stuff. And you know, so fortunately, this is going to be a horizontal one, so this is going to be rather easy to draw. So we want 6 sides. It's not for construction. So if we go here and we select on the thing, this is in yellow. You may or may not be able to see it, but notice how it wants to snap to the plane, and that's good. And it definitely wants to snap, you know, to that circular quadrant piece. So if I just click there, it's now snapped exactly where we want it. And that works out. So it's snapped there, but you can add relations to make it horizontal or parallel or whatever way you want to clock this thing. But often there are snaps that let you put it where you want. Exit sketch, and now we're going to do a feature extruded cut. And we're going to make this 1/2 inch deep, 0.5. And we're going to do it blind. And then let's look at flip side to cut. Okay, so see, now it's going to cut out the other side. So this little arrow flipped from inside to outside there. And so if we hit check, and now go to an ISO view, oops, we now see that we have our hex cut. And in this case, it's going to be easier to see if I just shade it. So there is our hex cut. So again, this was actually, you know, a lot of pages, but a lot of the pages had nothing to do with creating the part. So let me just do a save as, and this is going to be the offset shaft. Again, with my initials, you'll put in your initials, and then you hit save.